Why would anyone take millions of dollars worth of computer equipment and deliberately sink it to the ocean floor? That's exactly what Microsoft did in 2018, and when the tech world found out, the mockery was instant. But this wasn't a mistake. It wasn't a marketing gimmick. It was one of the most important experiments in data center history. And when the results came in, they shocked everyone, including Microsoft themselves. Project Natick. That's what Microsoft called it, and from the moment it was announced, it sounded like science fiction. The concept was simple, yet absurd. Take a data center, one containing hundreds of servers capable of processing millions of requests, seal it inside a waterproof cylinder, and deploy it on the sea floor. Leave it there for years with no human maintenance, no technicians to swap out failed drives, no engineers to fix broken cooling systems. Just let it sit in the cold, dark depths of the ocean. The idea came from a Microsoft employee who had served on a submarine. He understood something most data center engineers didn't. The ocean is actually an ideal environment for computers. It's naturally cool, the temperature is stable, and if you can solve the engineering challenges, you eliminate dozens of the problems that plague traditional data centers. But there was one massive problem. Everyone thought it was impossible.
Now, let's understand why the skepticism was so intense, because the concerns were legitimate. The first concern was the corrosion problem. Seawater is one of the most corrosive substances on Earth. It destroys metal, degrades seals, and finds its way into places you'd never expect. Data centers on land already struggle with humidity. Imagine submerging one in salt water. One tiny leak, and millions of dollars of equipment becomes a useless pile of corroded circuits. The second concern was the heat problem. Yes, the ocean is cold, but computers generate enormous amounts of heat. A single server rack can produce as much heat as several household ovens running simultaneously. In a traditional data center, massive air conditioning systems and cooling towers work around the clock to dissipate that heat. How do you cool servers in a sealed steel tube at the bottom of the ocean? The third concern was the maintenance problem. Data center components fail constantly. Hard drives crash, power supplies burn out, network cards malfunction. On land, technicians can walk in and replace failed components within hours. At the bottom of the ocean, you can't just send someone down to swap out a failed server. If something breaks, it stays broken. The fourth concern was the power problem. Data centers consume enormous amounts of electricity. Some large facilities use as much power as a small city. How do you deliver that much power to the seafloor? And what happens if the cable breaks? And finally, there's the environmental concern. Submerging industrial equipment in the ocean sounds like an ecological disaster waiting to happen. What about marine life? What about heat pollution warming the surrounding water? What about the noise? These weren't trivial concerns. They were fundamental engineering challenges that had no obvious solutions. When Microsoft announced they were actually going to attempt this, the reactions ranged from curiosity to outright mockery. However, Microsoft didn't start by building a massive underwater data center. They started small. In 2015, they conducted Phase 1 of Project Natick. They built a small prototype about the size of a shipping container and deployed it 30 feet underwater off the coast of California. It contained a single server rack and was designed to answer one simple question: can servers even survive underwater? For 105 days, that prototype sat on the sea floor while Microsoft monitored every sensor, every temperature reading, every potential failure point. And at the end of those 105 days, they had their answer. It worked. Not only did it work, but the data was promising. The cooling was more efficient than expected. The stable temperature of the ocean eliminated the thermal cycling that stresses components in traditional data centers. There were no leaks. The marine environment seemed less hostile than anticipated. But Phase 1 was just proof of concept. It was a tiny experiment in shallow water with constant monitoring. The real test would be Phase 2, a full-scale data center deployed in deep water, left untouched for years. This is where things got serious.
In 2018, Microsoft built what they called the Northern Isles Data Center. This wasn't a prototype. This was a fully operational data center designed to handle real workloads for real customers. The specifications were impressive. The cylinder was 40 feet long and 12 feet in diameter, about the size of a standard shipping container. Inside were 12 server racks containing 864 servers and 27.6 petabytes of storage. That's enough computing power to serve several million users. The entire structure weighed 40 tons when dry. They manufactured it in France, where it underwent months of testing in a pressure chamber to simulate deep water conditions. The cooling system was ingenious. Instead of using air conditioning, the cylinder used a heat exchange system that transferred heat from the servers to the ocean water flowing around the outside of the cylinder. The ocean itself became the cooling system. No moving parts, no refrigerants, no energy-wasting air conditioning. Just cold seawater absorbing the heat and carrying it away naturally. For power, they ran a cable from shore that delivered electricity and data connectivity. The entire system was designed to operate for 5 years without any human intervention. The deployment location was strategic. They chose the waters off the Orkney Islands in Scotland. This location had several advantages. The water was cold year-round, which improved cooling efficiency. The area had access to renewable energy from nearby wind and tidal power installations, and the seafloor, at 117 feet deep, was stable and relatively flat. In June 2018, a specialized ship towed the Northern Isles to its deployment location. A remotely operated vehicle guided the cylinder to the seafloor. And then they turned it on and walked away. Now came the real test. Could it survive? Would it work as designed? Or would Microsoft have to sheepishly retrieve a broken, corroded failure from the ocean floor?
For 2 years, the Northern Isles sat on the seafloor, processing real workloads for Microsoft Azure customers. During that time, Microsoft monitored it remotely but couldn't physically access it. If something failed, they could only watch it happen. And things did fail. In any data center, component failures are inevitable. Hard drives crash, power supplies fail, cooling fans stop working. In a traditional data center, these failures are routine maintenance issues. Technicians replace the failed components and operations continue. But in the Northern Isles, there were no technicians. Failed components stayed failed. Microsoft's engineers could only monitor the failure rates and hope that redundancy would keep the system operational. Meanwhile, the skeptics were waiting. Surely the failure rate would be catastrophic. Surely the sealed environment would accelerate component degradation. Surely this experiment would prove to be an expensive mistake. In 2020, 2 years after deployment, Microsoft made the decision to retrieve the Northern Isles. Not because it had failed, but because the experiment period was complete. They needed to examine the hardware and analyze the data. A team of specialists, working from ships and using remotely operated vehicles, carefully raised the cylinder from the seafloor. The retrieval took an entire day. When they finally hauled it onto the deck and opened the hatch, they discovered something remarkable.
The results weren't just good. They were so much better than land-based data centers that it almost seemed impossible. Here's the headline finding. The underwater data center had 1/8 the failure rate of a conventional data center. Read that again. Not slightly better, not marginally more reliable. 1/8
The failure rate. In a typical land-based data center, servers fail regularly due to a combination of factors: temperature fluctuations, humidity, corrosion from air pollutants, physical vibrations, and human error during maintenance. The Northern Isles eliminated or reduced nearly all of these factors. The stable temperature of the ocean eliminated thermal cycling, which is one of the primary causes of component failure. On land, data centers experience temperature variations as cooling systems cycle on and off, and as outdoor temperatures change with weather and seasons. These thermal expansions and contractions stress components, particularly solder joints and circuit boards. Underwater, the temperature barely fluctuated. It remained a constant cold temperature year-round, day and night, summer and winter. The sealed environment eliminated humidity and air pollutants. On land, data centers constantly battle moisture, dust, and corrosive gases that sneak in through ventilation systems. These contaminants degrade components over time. The Northern Isles had none of these problems. Perhaps most surprisingly, the sealed environment also eliminated human error. There were no technicians accidentally bumping into servers, no maintenance activities that inadvertently caused problems, no human-introduced variables at all. The nitrogen atmosphere inside the cylinder also played a role. Instead of air, Microsoft filled the cylinder with nitrogen, which is non-reactive and doesn't promote corrosion like oxygen does. The energy efficiency results were equally impressive. The Northern Isles used significantly less energy for cooling compared to land-based equivalents. The ocean provided free, constant cooling with no energy expenditure beyond running the pumps that circulated water through the heat exchangers. Microsoft also discovered that marine life actually benefited from the structure. Fish and other sea creatures used the cylinder as an artificial reef, congregating around it for shelter. There was no evidence of environmental harm.
So Microsoft proved you can put a data center underwater. But why does this matter? Why should anyone care? The answer is because this solves some of the biggest problems facing the internet. Problem 1. Location. About 50% of the world's population lives within 120 miles of a coast. Data centers need to be close to users to reduce latency, the delay between requesting data and receiving it. Every millisecond matters for applications like video streaming, gaming, and video conferencing. But coastal real estate is expensive and limited. Putting data centers offshore solves this problem elegantly. Problem 2. Cooling costs. Data centers consume roughly 1% of the world's electricity, and a significant portion of that goes to cooling. As our demand for computing continues to grow exponentially, so does the energy required to cool those computers. Ocean cooling is free and renewable. Problem 3. Renewable energy. Offshore locations are ideal for renewable energy. The Orkney Islands installation used wind and tidal power. Underwater data centers could be deployed near offshore wind farms, creating a symbiotic relationship where renewable energy directly powers computing infrastructure. Problem 4. Speed of deployment. Traditional data centers take years to plan, permit, and build. The Northern Isles was manufactured, deployed, and operational in months. In a world where demand for computing capacity is exploding, this rapid deployment capability is invaluable. Problem 5. Reliability. The 1/8 failure rate means fewer outages, lower maintenance costs, and better service for users. It also means data centers can be smaller and still deliver the same effective capacity.
After the results were published, the conversation changed. Some critics remained skeptical, raising valid questions. What about retrieval and recycling? When the hardware reaches end of life, you have to pull the entire cylinder up, which is expensive and complex. What about repairs? The no-maintenance design works until something critical fails. A land-based data center can replace a failed network switch in hours. Underwater, you either accept the failure or retrieve the entire cylinder. What about scaling? One cylinder is an experiment. Could you deploy hundreds or thousands of these? What about the cumulative environmental impact? What about security? Data centers on land have physical security guards, cameras, and controlled access. An underwater data center is harder to physically secure against determined attackers. These are legitimate concerns, and Microsoft has acknowledged them. But the company has also made it clear this wasn't just an experiment for the sake of experimentation. They're seriously considering underwater data centers as part of their future infrastructure strategy.
However, Project Natick officially concluded in 2020, but its impact continues. Microsoft hasn't announced plans to deploy production underwater data centers at scale, but they haven't ruled it out either. Other companies are paying attention. The demonstrated success of the Northern Isles has sparked interest across the tech industry. Several startups are now exploring commercial underwater data center concepts. The technology also has applications beyond commercial cloud computing. Military and research organizations have expressed interest in deployable underwater computing infrastructure. Imagine oceanographic research stations with built-in computing capacity, or defense installations that can be rapidly deployed and are naturally protected from many threats. The Northern Isles cylinder itself was eventually recycled, with 99% of its components recovered and reused. Microsoft studied every component, documenting failure modes, analyzing wear patterns, and learning everything they could. The lessons from Project Natick are already influencing land-based data center design. The insights about temperature stability, atmospheric composition, and maintenance reduction are being applied to conventional facilities. Here's what Project Natick really represents: a fundamental rethinking of where and how we build data centers. For decades, data center design has been evolutionary, not revolutionary. We built bigger buildings, more efficient cooling systems, better power distribution, but the basic model remained unchanged. Large buildings on land, filled with servers, and supported by armies of technicians. Project Natick asked a different question. What if we didn't need the building? What if we didn't need the technicians? What if we eliminated the variables that cause problems instead of building systems to manage those variables? This is innovation at its finest, not incremental improvement, but reconceptualizing the entire problem. And it started with an idea that made people laugh.
When Microsoft announced they were going to sink a data center to the bottom of the ocean, the laughter was immediate and widespread. It sounded absurd, impractical, and doomed to fail. But Microsoft didn't let the skepticism stop them. They started small, tested their assumptions, learned from the data, and scaled up systematically. They addressed legitimate concerns, over-engineered the critical systems, and prepared for failure. And then they succeeded beyond even their own expectations. The Northern Isles data center didn't just work. It worked better than conventional data centers. It proved that sometimes the craziest-sounding ideas are crazy only because no one has tried them yet. Today, underwater data centers might still seem like a novelty, an experimental curiosity, but that's exactly what people said about cloud computing 20 years ago. It's what they said about electric cars 15 years ago. It's what they say about every breakthrough until it becomes the new normal. The next time you stream a video, send an email, or access a file from the cloud, remember that somewhere, engineers are rethinking everything we assume about how the internet should work. They're questioning conventions, testing wild ideas, and occasionally sinking data centers to the bottom of the ocean. Because the future belongs not to those who mock the unusual, but to those who dare to test it. Project Natick proved that sometimes the best place for a data center isn't in a warehouse in a desert. It's at the bottom of the sea.